Okay, so as we're going through the DDL slides, what I would actually recommend is when you're watching this at home, what I would do is sort of go back to our schema, take a screenshot of that and that slide and actually open it up maybe on the side or on another screen, so that way as we go through these slides and look at the DDL statements, you can refer right back to the schema and see where we're getting the column names and references from. But besides that, we're basically, what we're going to do here is, like, we have split them into three separate sort of clusters where the tables are more related to each other, and we're kind of going to go through each cluster in detail. Okay, so this first section here is basically keeping track of the employee, member, and membership type tables. And remember, so we talked about how the library is going to have members. The members are going to have different membership types. Membership types have the different type of rules, meaning the late days allocated, concurrent checkouts, the late fees that they're paying per day. And then the library also has employees who have a certain type of membership. Okay, so as you're kind of looking at the DDL statements here, they're pretty standard statements, right? Nothing too crazy going on. So if we start with the employee table here, you see our primary key is going to be employee, and usually, typically you'd have that as your first column, your first attribute that you named in the DDL statement. Then you actually make it a primary key in there. Then our member ID, which is going to be our foreign key. Then you see here, this foreign key is, we have that referential integrity being notated here, where it's going to be referring to the primary key of member, which is right there, right? So yeah, so that's sort of how you would join those two tables when they're going to be used. And then besides that, in the employee table, you just have other attributes like job title and hire date. Again, just like some other attributes that might be needed for employee. Okay, and then again, if you're looking at the schema on the side of this, you can sort of see how we've gotten everything. So that's employee, member, again, self-explanatory, pretty standard DDL statement here. Your primary key is your member ID, which is the first one. Your membership type ID is a foreign key here, and this is what's going to refer to the membership types, the primary key there, which is that. Then some other attributes, first name, last name, email address, and so on. Then you have your membership types ID, your membership types table. That's your primary key here. Note one thing you realize here that is you have the foreign key reference being done in the table that it's going to join to. So there's no foreign key referential integrity statement here in membership types. It's just in the table that's going to be using it. So member here is going to be joining to membership type. So that's why we have this statement over here. But then membership types, that table is pretty simple, where you just have some other attributes, title, then the other things that are going to be associated with the membership type. So the number of late days they have, the fee, and so on. Okay, so this was sort of that cluster to keep track of employees, members, and membership types. Remember, one of the other key tables in our design was the transactions table, or rather the item checkouts table, which is going to be keeping track of those transactions. So you see we had our item checkout ID, we're using that as our primary key. We had two foreign keys here, our product item ID and member ID. Then you see the two referential integrity statements here. The product item ID, that's going to refer to the product item table, which you'll see in the next slide in like the product cluster. Then you have the member ID that's referencing the member table there. Then besides that, you just have the checkout date, then the other dates that are going to be associated with the checkout. And one thing I think I didn't mention on the previous slide either, you also see the other statements we're putting in here where we're telling it what the domain is. So in this case, these are ints, these are dates. Then other constraints such as what's null, what's not null. And typically you can see that in this table, these three columns are going to be not null. And that's mainly because those three keys are what's used as primary keys and foreign keys. It's really a table design decision on whether you want to have foreign keys be nullable or not. In my case, in our case here, item checkouts really wouldn't make sense if you have one of those foreign keys blank, where if the member ID is blank, that means the item has been checked out and you don't know by whom. So those are things we're going to enforce. Again, these are just design decisions, and you kind of talk to your interviewer about pros and cons as you go. Moving on, last cluster here is sort of the products, and then like the three levels of granularity we talked about. Not going to go through these in detail, but basically you see the very top level granularity is going to be your first table here, your product line, which is, let's say this is the Harry Potter series. Product is going to be your second layer of granularity. That's going to be the Harry Potter part 1, part 2, part 3, and so on. Product item is going to be your most granular, which is kind of a sloppy 3, but basically those are the individual copies that are available there. And then if you kind of go through it, you see the same practices before: foreign keys, primary keys. Then you have those constraints here. Note also for product, you have 3 foreign key references. One is to that first granularity product line table here. Then the other one is a publisher ID, which is going to join to this table. And then you also have the author ID, which is going to join to this table here. Okay, so if you sort of kind of had paused the video and then looked at the statements in detail, you'll see that these are pretty standard DDL statements. There's nothing too fancy going on besides some non-null constraints, and then some referential integrity statements for the foreign keys. And with that, we're basically just going to finish up by looking at some of the Sql questions that might be asked for the library data design. So the first question here, this is one that was kind of given to us in the beginning. Find how many copies of that book, Principles of Database Design, written by J.D. Ullman, are currently in the library and are issued. So now you see the key points here are how many are currently in the library and are issued. Remember, this is one where we kind of got those initial requirements of I want to keep track of books that are available in the library, and then ones that are checked out. So that was kind of one of our key, this is one of those key questions that helped us in that design, right? Because of that, we know we're definitely going to be using that item checkouts table. That's actually key to tracking those transactions, right? And then we're also given the name of the book, Principle of Database and Knowledge Base Systems, and written by J.D. Ullman, right? So that's author. So if I were to sort of start this query, what I would do is first usually whenever I write a query like this and I know that I have an end goal in mind, I'm basically just going to start with my from statement over here. And what I'm basically just going to do is bring in all the tables I know that I'm going to be needing to answer this question and join them on the primary keys and foreign keys. So you see I first brought in the product item table. Again, that's the one that's going to keep track of the individual copies. I know I'm going to need that because I want to see how many copies are in and are not in the library. I'm going to join it to the product and author table because product, I'm going to need that second level of granularity again to filter on the title, and then I'm going to filter on I can filter on the author as well. So that's why I brought those two in. And then notice I do a left join on the item checkouts table. And then you see this join. What I'm basically doing is I'm joining on the product item ID, which is the foreign key in the item checkouts table, to join to that. But then I also join on return date being null, because basically what that's going to do is that's going to get me all of those books that are currently in the library and issued and are currently issued, right? So the ones that are in the library, those are going to have a blank in return date because they're available. The ones that are issued out and checked out by somebody, those are also going to have a blank return date because they haven't been returned yet. If I hadn't done this join, I would have basically gotten all the records and item checkouts for this book, which I've filtered by there. So what would happen if I did that is since I'm getting all the records, I'm also going to bring in all the records of when it was checked out and returned already before, because I'm using that item checkouts table. But if I filter on the return date being null this way, I'm able to look at only the ones that are currently issued and currently available in the library. And then what I basically do is I just want to count each of them. So what I do is in my select, I'm gonna select the name just so I have something to group by. And then you see these two case statements here that I'm adding up to look at the total number that are checked out and the total number that are available. So the total number that are checked out is basically the ones where the checkout date is not null. And so if the checkout date is not null, that means there's a date there. That means somebody has it out. So then I'm going to count that as a book that's checked out. But if the checkout date is null, and remember, since I did that join on the null return date, that's bringing in all the titles that are available or issued. So if they're already there, if I know they're available or issued, and the checkout date is blank, that means I know it's not checked out. So that's going to tell me which one, how many are available in there. So I'm able to kind of put that logic in a sum statement, and then I can say if it's not null, then 1, otherwise 0, then I'm going to add that up as checked out, and sort of the opposite for total available. And then I sort of group by the name. And then once this runs, I'm able to group by the name and then see how many are checked out and available. Okay. Moving on to the second question. This one is how many of the Harry Potter and Sorcerer's Stone copies are currently available to be borrowed? Okay, so this, and then what about for all 7 Harry Potter books? So what I'm actually going to do in this, in answering this, is I'm just going to go to the second part right away. What about for all 7 Harry Potter books? Just because that way I'm going to be answering the first question at the same time too. Again, I start with the from statement and bring in all the tables that I'm going to be needing. And basically this is using Harry Potter, which is an example we've been talking about all along. So I know I'm going to need all 3 granularities of the of those products tables that we made before, right? So I'm going to need product item, I'm going to need product, and then I'm also going to need product line, which is the top level one. Looks like I brought in author, but it doesn't seem like I used it, so we could just ignore that for now. But so I bring in all of those, and then I'm basically checking something similar to what I checked in the previous question: how many are available to be borrowed, which is kind of also going to tell me how many are going to be available that are already checked out, right? So I can just do that same join on item checkouts and return date being null. That way I know that way I know I can keep the records where the title hasn't been checked out yet, so I can see how many are available. And then you see I'm basically filtering in the product line table by Harry Potter, because I want to get all 7 Harry Potter books. So I filter by that, but then in my select, I'm selecting p.name, which is the second level granularity of product. So this one is going to give me Harry Potter part 1, part 2, and so on. Harry Potter and Sorcerer's Stone, so that's part 1, right? So this way I can see it for all of them. And then I basically use the same logic that I did in the previous question, where I can check that checkout date to determine whether it's checked out or available, and just kind of wrap that in a sum function to be able to get a total number of how many are available and checked out. Okay, moving on to the third one. So this question is saying, for all books that were borrowed in 2020, what's the amount of late fees that have been collected? Okay, so this is using that transaction table again, and I'm going to be looking at late fees, right? And remember, late fees, I'm going to be getting that from the membership types table, because that's the one that has information about the late fees per day and how many days they're allocated, how many free late days essentially that the person's being allocated, and so on, right? So again, like before, I'm basically just going to start in the from statement and bring in all the columns I know, all the tables I know I'm going to use. So that's item checkouts, member and membership types, because ultimately I care about membership types, but the only way I can join two membership types is item checkouts to member first, and then from member to membership type. That I did here, and then I did the first one over there. Okay, and then actually this is a mistake. So here you see I filter for 2022. That should actually be 2020, but it's the same idea really. Yeah, so let's say, yeah, so let's imagine that was a 2020, right? But okay, so for all the books that are borrowed in 2020, that's my filter for the checkout dates year. So I want to look at the late fees. So late fees so what's the total amount of late fees that have been collected? And then I'm going to assume here that if a book was late and it was returned, that means the late fee has been collected. So let's say I want to look at books that have been returned. So I'm gonna look for ones that were checked out, but the return date is not null, meaning the book has been returned. And then I want to get the total. So I basically have like this big case when statement to calculate the total amount of fees that were collected, right? So I'm basically going to see when the return date is before the scheduled return date. So that would mean the book was, so you see the comment there. So that would mean the book was returned before or on the date the book is due. So in that case, there is no late fee. You see this other statement over here. So this is just one case where here the fee is 0. The other case is the book is within the grace period. So that would also mean it's in 0. And the book we know is within the grace period is basically, so you see here this date diff between the return date and scheduled return date. If that is less than or equal to the late days allocated. So if that's within that time period, there is no late fee. So whenever those are true, my fee is 0. Otherwise, you're gonna have a late fee. And that's what this else statement here is gonna calculate. So otherwise, you have the late fee per day, which is, again, remember, this late fee per day is from the membership types table, times the number of days it was late, right? So that I can get the number of days it was late by that similar statement to above, where I'm basically just going to take the difference between the return date and the scheduled return date, but I'm also going to subtract the number of late days allocated. So let's say I was late returning something by 5 days, but I was given 3 late days that are allocated to me. So if I use, so it's 5 minus 3 is 2. So I'm only going to be charged for 2 days with that period. So that's why I do that subtraction there. And then that multiplies by the late fee per day, and then it ends up being what the total was. And then since I sort of sum everything up there, this is going to give me the total that's been collected based off of the books that were borrowed that were returned late. Okay, moving on to the last question actually. Sort of building on that previous question. So the question here is, what's the total when you include the total amount of late fees from books borrowed in 2020 that have yet to be returned? So we're basically saying, so remember back in this query, we did this over here, right? Late fees that were collected because the return date is not null. So now it's saying, what about the books that are late, but they're still out there, right? So one thing we could do, one thing we know is that if we wanted to calculate the late fee, we need to know when it was returned because you're charged a late fee per day. So what we can do is assume that, okay, if it's still out there, let's do the calculation assuming that the book is going to be returned today. And you see, so that assumption, if I was doing this in an actual interview, I would say that to the interviewer, that I'm making that decision, that this is how I'm going to write the query. So again, kind of goes back to wanting to communicate with your interviewer as you go and kind of take them through your thought process. Okay, but you sort of look at this and you see it's not too different from what we had in the previous question, where again, in our first thing, we're taking the same tables, Notice the one thing that's missing. So this should be 2020 like before, but you see what's actually missing is this return date is not null filter, because I'm going to be looking at the ones that haven't been returned. So I don't want to filter them out. So then when I'm adding up the actual fees, it's pretty similar to before, where our first two cases is going to be the same, where this is going to be a no fee and this is going to be no fee. Either it's returned when the book is before the book is due, or it's within the grace period. So there's no fee then. But this is a little bit different. So what I'm going to do again is I'm going to multiply the late fee per day times the number of days it was late by. So what I would do is we basically just need to account for the books that have yet to be returned. And remember, those still have a blank return date. So, but I want to basically, so since that blank return date, I want that to represent today instead of being blank. So what I would do is just use this coalesce statement here and then do the same thing I did before. So here, I'm basically either going to get the return date, or if the return date is blank, I'm using the today function to get today's date. So this is basically going to implement that assumption we made before, where if the book hasn't been returned, let's calculate the late fee as if it were to be as if the book were to be returned today. And then it's pretty similar to before, where I'm doing the late fee per day times the number of days that it was late, whether it was a return date or today, here. So that minus the number of late days allocated, similar to before, just multiplying that by the late fee, and then I'm going to get the total that I'm summing up here. Okay, and then I think yeah, so it looks like that's actually it for the library design question. Hopefully you got some out of this session, and hope you come for the next video.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today